before class next time. So before Thursday. You don't get this one? What are we doing in class today? Seth? You said you didn't understand it?
Yeah, I don't understand this
What are we doing in class?
one. Sorry, what did you say? What do I do? What do we do in class?
What are we doing in class today? More.
We're doing volumes of revolution notes.
So more volume?
Oh my gosh.
Turn the volume up.
That will do me for
Happy Pi Day.
Hi.
It's not a real holiday.
You should celebrate.
We should make it a real holiday.
It's just like,
They should make
this
it
is a
fun.
pivotal math.
Petition to get school.
And then they should bring pie in, you know what I mean?
They do bring pie in.
I know.
But
Wait,
just
can I still get some?
Yes.
I think it's open until 2.
Really?
Rose and math
Oh,
teacher
we're
who
gonna
doesn't
be
celebrate
here.
Pi Day.
Darn it. But I can't-
Mr. Talent, that's so disappointing.
Wait, where'd you get the pie?
Okay, but pi is not 3.14.
Okay,
Well, it
basically.
is. Well,
That's-
basically the first three numbers are, and then.
That's always what you rounded it
And
to.
celebrate March 14th at 1:59.
Well, that's actually during this class, so get ready.
Yeah.
Well, for 1 second, sure.
I'll celebrate it for
Like,
one
whoa.
minute. You don't like Pi Day. He's fed up with me being enthusiastic.
I like Pi Day because there's pie involved.
Oh, facts. I just gotta find his interests. What's that video game he plays? He plays a little Okay, I'll find the national holidays for those. Maybe one day he'll appreciate it.
Or you should go the other direction and just start trying to find every single holiday. Like every day is a national something. Like happy American Disability Day or whatever.
Just keep trying. Just keep trying. I don't know. But it looks good.
What? You taking the bite out?
No, I'm saving it for Outlaw.
Oh, so you're just gonna let it sit there?
Yes.
Actually, yeah, that's really
I get really surprised.
Yeah, we're trying to work on it.
I just keep guessing through Outlaw.
Should have done something higher.
Alphabetical. Oh, how did you do in the tennis quiz?
Oh, I got a nine.
It's actually enjoyable.
I bet it sounds stupid.
You know what I
The volume guy?
I
Yeah.
forgot to put
More volume.
There
you go.
That is probably what I do.
Because
Because I was like, should I put the charge? And then I put the charge in one. Oh, yeah.
Philip.
You know what, I'm kidding.
I just, it just,
It's
forgot. Makes me mad.
For me, bro, I don't know. There was like no. I don't
Karina.
know if there was multiple questions. Like one you have to like
Still had that line.
very few things that, there's very few things
I
that
know
make me
how
happy
it
today.
works. I just don't know how to
I
explain
like
it.
Miss Stewart-Briggs jokes.
That's the like.
It's so funny.
Yeah.
Oh my god, I love her.
she's coming back next year.
Sometimes I think my game is broken, but like,
So I thought,
I would know my game is broken.
yeah, no, it's but
Yeah,
It isn't as hard
we were
as
like, good, cool. And then she opened it up and she found out that I also looked at the with the same message, so, I've known on the roommate. It messed me up. So are you gonna get assigned a new one or just? I'm looking for a new one,
Well, let me
and
guess
if I
why.
don't.
All right, we need to get started here. Our bells are turned off for some reason, but I don't want y'all to have more homework than necessary.
1592. I did 1592.
That's gonna
You can just sit in there. Thank you. Huh? Yeah, we're getting there. We're almost there. I'm being patient. Okay, so we need to take a couple quick notes today. This is the handout you picked up, number 103. So the topics that we have currently done from the very last unit include finding area between two curves, which I'm actually going to ask you to go back and practice some more of today after we do this short new piece here. Something called L'Hopital's rule, which I showed you a long time ago last semester that we'll need to review. And we did volumes from known cross sections, which we did some practice on a couple classes ago, but we will need a little bit more practice on that before you could be expected to test on it. But the last type of topics, they are both volume related, and we are going to look at some basic ones of the first type. So the first type being something called disc method, and then eventually we'll do some washer method. Okay, so these notes are super short, so I need y'all to make sure that you've got your full attention here. And then I will ask you to slide over and do just one Khan Academy assignment on this to basically make sure that you understand how to set these up, the topic that we're just about to talk about. And then you can have the rest of class to finish up that area between two curve circuit that we started last week. Okay, so we have talked about how integration can find you area under a curve like this. Of course, area is a two-dimensional shape, but in the last two topics that I need to show you before we're in full AP review mode is now what we're going to do is we're going to take this two-dimensional area and we're going to rotate it. So usually around the x-axis or the y-axis. So if I spun this area around the x-axis, it would create this three-dimensional shape. Can y'all visualize that? Okay. You need to be able to find the volume of those three-dimensional shapes. So they certainly don't fit some geometry shape, so there's not just some formula that you can plug the stuff in. But we are going to be able to dissect all of these into an infinite number of circles. Notice there's a circle right here. Anywhere you cut this shape vertically, you're going to have circle cross sections. So here's one shown to you. Okay, so really all we're going to do is use integration to add up an infinite number of circles, and when you add up an infinite number of two-dimensional shapes, you're going to end up with the volume of a three-dimensional shape. Okay, so I've got one of each of these that I'm going to do for you, and then one of each of these I want you to try before we go over them. Now this is actually called the disc method. This is just a typo. Next class we'll talk about washer method. Washer method is really the same as this method plus one more step. So it's not that it's that much harder, but we can just focus on this today. All right, so we're going to sketch these two graphs. Y equals 0. And y equals x squared minus 3. Now your graph doesn't have to be perfect, but the better your graph looks, sometimes the easier it is to figure out what you're doing. But this question goes on to say that we have a region enclosed by these two curves. So the area that's trapped in between these two is the area that we're going to spin. Now, sometimes you're going to rotate it around a horizontal line, like the x-axis. Sometimes a vertical line, like the y-axis. Those would be the only two that we look at today. But similar to what we did last class, if you're spinning it around the x-axis, you want dx when you integrate. You need to use the left and right bounds. So if you figure out where these two things intersect, be careful not to say that it's 2 and negative 2. It's actually square root of 3 and square root of negative 3. Now here's the important part. This is the conceptual piece that's going to determine how difficult you think this is. When we spin this two-dimensional shape, obviously I can't sketch this to make this look like a great three-dimensional shape, and most people can't. But when I spin this right here, this doesn't have very far to go, so his little circle cross-section that he makes is going to be pretty small. But then as you move closer to the center, the cross-section is going to get bigger and bigger, and then start to go back down. So do you guys see how that area would flow into those spaces, those circles? All right, well, if integration is a mathematical way to add up an infinite number of things, and I want to add up an infinite number of circles, if I really find all of these circles, an infinite number of them, infinitely thin, well, how do we find the area of a circle? So I'm going to integrate pi r squared. The only thing you really have to be careful about is determining what you think r is. And this is where the picture kind of helps. So this one goes down, but this distance is y, so this distance is y. This is y, this is y. So what would you say the radius is?
2y.
The- Okay, so here would be the radius, here would be the radius, or maybe it makes more sense to draw them down. But the radius is y, the distance from the x-axis to the function. I'm just drawing them up instead of down, but it's the same distance. But we need these variables to match. We don't want y's here and x's here. So instead of calling this y, we will put what it's equal to in terms of x, and that integral is what would give you the volume of that three-dimensional shape.
But not 2y?
Yeah, it's just
Oh, okay.
yeah, these purple circles, we're visualizing the radius in there. It's just 1y. The radius is 1y. So again, I'm integrating dx because I'm rotating it around the x-axis. I use left and right bounds because I was rotating it around the x-axis. And then the rest of it is I'm just adding up an infinite number of circles, which is pi r squared. But r is going to change from question to question. So, all right, so I've only got one of these on our notes for us to practice. So if you would, go ahead and sketch these two. Look at the area trapped in between it, and then think about what integral you would have to set up to do the same thing I did in question 1. So it's okay if you don't get it right, but go ahead and start it and at least see what parts you feel like you can do. Okay, so when you set up your integral, again, you don't need to solve it. We can always solve them later. Did you pick dx or dx or dy and y?
Yep.
Yes.
Okay, Karina, why? Okay, because of that, that determines that. Okay, did you pick 0 to 4 to be your bounds? That would be the y values. We want -2 to 2. Far left and far right because we're rotating it around the x-axis. Okay, and then the rest of this is always going to be what? Because we're adding up a bunch of circles, it's always going to be pi r squared. You just need to slow down and think about what you think R is going to be. So you don't have to do a bunch of these. You don't need your picture to look three-dimensional, but you're doing yourself a disservice if you don't sketch in a couple of the circles. Right here, rotated, would make a pretty small cross section. Here is going to make the biggest cross section. Here, somewhere in the middle. But now that I can visualize that, the radius is always equal to what?
Y.
The distance from the x-axis to the function. But you didn't leave it as y because you need these variables to match. So instead of calling this y, you called it
Negative x squared.
right, what y was equal to. That's what you were aiming for. That will add up an infinite number of circles in the x direction from here to here. And when you add up all those circles, an infinite amount of them, it ends up being a three-dimensional shape. Okay, y'all accept that?
Why could my zeros be square root of 4? Oh wait, hold on, that is perfect. Okay, yeah, we're on the same page. Yeah, we're great.
We're done? Okay.
Yeah.
Okay, now let's look at what's different if it's the y-axis. So you still want to give yourself a picture. These are supposed to say x equals, they got cut off. But you want to give yourself a visual, x equals 0, y equals 0. Also maybe graph this guy. Questions will be unnecessarily tricky if you don't have some kind of visual to look at. Now, because we're rotating this around the y-axis, what is one thing that you think will be different?
dy.
Very good. It's going to be dy. And instead of getting your bounds from the far left and far right, it's going to be from the far bottom to the far top. Although technically in this question you would still accidentally get it right, because this is 0 to 8 as well, and this is 0 to 8. But dy, you need to be looking at bottom y value compared to top y value. The rest of this stuff is always going to be what?
Pi r squared.
Pi r squared. What?
Isn't it a triangle though? Don't we use pi r squared for the
But we're not finding the area of a triangle. We're finding the area, we're finding the volume.
because we're still doing the thing.
Yeah, the volume of the shape if we rotate this around the y-axis.
Okay,
So,
yeah.
what do you guys think r is going to be? Very good. So you're on the right track there. This is where I think it's good to draw in a few circles. If I'm rotating it around the y-axis, right here, your cross sections are going to be pretty small, but your cross sections are going to get bigger based on that direction. All of these have a radius of what?
X. Like what are the values?
Right, all of these are x. We don't leave this because we need these variables to match, so don't call it x. Take this guy and solve him for x. Or I'm sorry, solve him for y. And then there you go. Pi r squared in terms of y. Yep.
So when you do this method, you always do pi r squared?
These will always be a bunch of circles, so always pi r squared, which makes it a little bit easier. Now, I've never thought about this until last period, but this one's kind of weird. Like, you don't really need calculus on this one, I wouldn't think. You see how this would just make a normal right cone? So, really, if you know the height and you know the radius, you could just plug that one into an old geometry formula. But since that's not normally the case, that integral would add up all of these circles, and when you have an infinite number of infinitely thin ones stacked on top of each other, you would have a three-dimensional shape. Okay, so try one more. This one is also about the y-axis. So see what you would come up with without any guidance, and then we'll try to help you make some corrections if need be. Okay, so assuming you have a sketch that looks like mine, what part of your integral should be pretty quick?
UI.
Okay, if you're rotating in about the y-axis, I agree. What about the bounds?
-5 to 0.
Very good. Using bottom and top because we're doing dy, not left to right. That was for dx. If you're rotating this around, oh, well also, these are always going to be a bunch of circles, so always pi r squared. Even when we do the washer method, next time, it'll still be circles, so it'll still be pi r squared. But you've got to be careful with determining this radius length. So if I rotate this direction, draw in a couple of your cross sections. 1 or 2 is plenty fine, but enough for you to see that your radius of any of these cross section circles is always going to be x. But then why is this not okay to leave it this way?
It's in terms of y.
Right, we need it to be in terms of y, so what did you replace this with?
Y plus 5.
Very good. You had to take this and solve him for x. So x is the same thing as y plus 5. If this is dy, you need this stuff to be in terms of y as well. So that integral is what would give you the volume of that shape. Okay? So since it's always circles and the setup has some structure to it, these aren't usually as difficult as students think that they would be. Okay, I don't know that you will need scratch paper, but if you do, please number it as 104. I picked out just one Khan Academy today to go along with these to get just a touch of practice. Most of them are just a setup where you don't even have to do an integral or anything. You just pick out the integral that looks correct. But you might have 1 or 2 that you actually need to solve, but you can use the calculator for that if you'd like to. So top priority is, there's only 4 questions there, so even if you miss some and you got to retry it, I would like you to finish that up first. And so my top priority will be helping people get to 100 on that. And then the sooner you make 100 on that, you're welcome to move on to the circuit from last week, 101. So I gave you some class time, but I told you you didn't have to worry about it for homework yet because there was no point in you doing it for homework when you had a test to study for. So go ahead and move on to that after you get 100 on this one, Khan Academy. And I'll be coming around to take your questions. Also, just before I forget here, if you did participate in ACTM, they did finally put out the test on their website, so I stole those and put them on my website. So if you kept your test and want to see which questions you got right and which ones you got wrong and what the answers were, that is on my class website. You just have to go to the ACTM section. Or if you didn't do the ACTM, but you're interested in what it was like and how difficult the questions and stuff were, it's on there now. So maybe you didn't do it this year, but maybe you want to do it next year. Okay, so as soon as everyone has 100 on the Khan Academy, then I will be happy to help you with the circuit. If you move on to the circuit sooner and you're impatient, you're welcome to pull up the videos from the website. All of the later questions have been worked out on there, so I will obviously help you with those as well. But my top priority is to make sure everyone's okay with the idea of the notes we took today.
answer, and then it wants it in terms of pi. So if all this comes out to be 100, your answer would be 100. Don't multiply the pi, just leave the pi in your answer. Just that without the pi.
Okay.
Wait, you got pi in there.
Oh. Type that in again. Without the pi. Pi is still in your answer, they're just saying don't multiply it. So your answer should be 18 pi. That looks a lot nicer than that weird decimal.
Yeah, it does.
Assuming that there's one set up there.
Yep.
Let's have
So, oh, 9, should be 9.
yeah. Now, another thing though is scroll down. This is saying give your answer in terms of pi. So type that in again without pi.
Okay. Why is
It-
that?
Well, because of the way they want the answer.
Okay.
They want you to say your answer is 18 pi. It's not that decimal.
So if I divided, I could also see this divided by 9, and this side divided by 5.
Yeah, if you remember to do that.
But,
If you guys aren't sure what it means by leave your answer in terms of pi, you might maybe come and help before. Oh. Yeah, pi is still part of your answer.
alright.
They just don't want you to multiply it.
What are you Sorry. Yeah, it's still
That's 15. By pi. Because I did physics only by pi, so I didn't have it by any, so I just had pi to it. So it's
should have been a 1/6 of this, this is a fraction. They're not gonna want you to do that. Roll up so I can push. Yeah, but see, that's not the same thing. 15.33 is not the same thing as that. Close to the same thing. No, I understand, but 15.33 is not the same thing as 15.33. So what you should have done is, done this. Now change it to a fraction. Now, here it is. Now change to a fraction. So they were looking for 46/3. No rounding. No rounding.
Oh, wait, no, my God, you see this. Yeah, I thought this was the question, and I was like, how am I supposed to know what the function is?
Very good.
I'll double check my work.
What?
Very good.
Yeah.
At least you're ahead of me. For class.
Mr. Thompson,
Can you check for something?
there was a problem going here.
Yeah.
I'll show you an image.
Hold on, let me get some of these scores.
I always see him. Shake hands with the spiel on every day.
Here's, should I try just for fun? The tennis team?
Between 6.
Fun, man, do it.
Dude, that'd be hilarious.
Do it for real.
Like, if I didn't actually got on that.
I think you could.
Are you gonna play next year?
Okay, Michael.
You varsity?
I think in the been here all years. We'll see though. I'm honestly like my class.
Okay, so those of you that are getting 100 on that one, please move on to the circuit. So I'm hoping you don't have much of any homework from that. But some of it depends on how quick you move on.
So, it says find the area of first quadrant region, and it's a cosine and a sine graph. And I found where they intersected, and it's that point right there.
The clouds.
That's close, but that's not exact.
Oh,
No, he just said.
Even 8 or 9 decimals can be awful. But,
okay. So how would I,
well, when are sine and cosine equal?
It's too bad.
oh, I would.
I was towards the decimal.
That's how.
Right, the decimal first. But that may not be your only question.
No, I see, 'cause that would have gotten me,
Howard's beating Kansas first round.
that would have gotten me genuine answers right there, and not decimals.
Yeah, no,
Because
guys.
to get that square root of 2, I basically had to do that and then set it equal. To solve that, to just find that and take the square
So
root.
you're actually making the question much harder.
Okay, No, I did, madness I predicted, I forgot who I predicted. I was wrong. Maybe a longest, perhaps. No, that's my goals. I'm taking my. Oh, you finished.
I thought it was homework. I thought it was homework
Yeah,
for today, so I did it last night. But
Okay. Well, I mean,
I also did that one too, so
oh, wow, okay.
yeah.
Oh.
You're psycho. Oh, I've been. I like doing Taxos better than anything lit. You don't celebrate Pi Day, Mr. Thompson? Did you celebrate Pi Day in 2015? If you were on a day,
1.142105.
215.
2015. It's like if you went on a date.
Oh.
3.142015.
No, he said I celebrated.
What about in
15.
1592? Would you have celebrated it?
Oh my god.
1592.
You pull out the trousers.
I'm not that old.
But if you were alive in and you were a mathematician, would you have celebrated Pi Day?
Oh,
Probably not.
What? It's the perfect day.
Imagine like founding
made up
like, the
holiday.
day afterwards, and you're like,
Did you buy them guys? Did you buy
like,
some?
we missed it, guys.
The last time somebody gave me a pie like over Christmas break and I'd eaten one piece.
What?
You just waiting to finish it or something?
Yeah, I just threw it in the freezer.
Oh, okay.
It's
Oh,
not a
okay.
big pie.
Wait, it's genuinely still in the freezer?
Yeah.
What kind of pie was it?
Pecan.
That's why.
Pecans, they can last. They can last. Or key lime.
There's better pies.
I have like some
Key lime pie is good. I already ate this today.
I don't understand why they're like, oh, you need to use key lime to the pie. I've made 2 pies. I was so fed up with the like, oh, key lime pie is so different from normal lime pie. But I bought key lime. I got key lime. I was like, I was in Florida. I was like, you can buy key limes and mail them to me. And she was like, okay. And so I had key limes and they were good and they were fresh. I made normal limes and there's no difference.
Okay, so.
I don't know. I had like a
Yeah, facts.
It's average. It's all pie. It's all pie to me.
Oh, every pie besides pie is still pie. Key lime pie.
Easily. I'm a cream.
Yeah.
What's your favorite kind of pie, Mr. Townsend?
My favorite kind of pie is when you
Oh, yeah,
eat your
I see.
words without me asking. In terms of pie.
I guess it's actually my best pass, Mr. Townsend.
Well, not at this rate.
Wait, what's now?
I'm not on 10. No, which one's 7? Which one's supposed to be 7? Because I got 8 wrong, according to you. And I trust you with
Well, we don't want to you guys.
Yeah, so that's why I trust you. If I was 7,
Wait, what did you get wrong?
I got
Oh,
something wrong with 7.
you might leave it out just in case I need to check. Thanks.
I just want to see if I got something.
No, I said it was 2.
Oh, this weekend? I don't even remember what I did. Just like some random class.
What? Yeah, square root of 2 minus. They're getting paused. I'm looking. I need to inspect my errors.
It's really fun, but I just not close.
Oh, you need
I feel like you'd be great because you're really big. Like you got
I used to play defense. I run pretty slowly, so that's the only thing I really need.
Also, speed. I have to get like I have to aim above a 93 in every class because like that's weird because in Massachusetts
The NBAs.
a 93 is an A.
What are they called? Vintage?
I mean, think about it. They have some of the things.
There's not experts for that.
A lot of, we do our grading system different. A lot of people have 93 through 100
I'll say
as
second.
A, and then
That's
A
square.
minus.
Sideways.
But an A minus doesn't count as 4 points for your GPA, which is 3.5.
Here?
No, in like other places. Not here. Not here. Not here.
Good thing I only have some.
I know, it makes.
No, it's not here. It's in other places. And like that's how. That's what it was when my mom was from Florida. That's how they do it. Some places do have even partial systems. It's really weird.
So, well, don't be jumping to conclusions. I would not. How did you come out of Massachusetts?
I mean, it's good. A lot of people like say it's good to at least take that grades. If you could at least take it for work plus so that you have anything to do with it, yeah. Like if you want to, like this is your
there are a couple people in this school that like.
It shows that you're well rounded, I guess. I don't know.
Are you serious?
Done?
Oh, no, it's, yes, sir.
Just learning about affirmative action.
The other ones.
But why do you read all your emails? Don't tell me you read all those emails.
That's how I remember.
I absolutely
That's how I
everything
remember
is
this.
easy. Yeah.
Shut up. Sounds how I remember like this way since
Shut up.
I read very specific emails.
I think you might wanna do this for.
I don't understand why my calculator is able to calculate what's happening. Try not to do right.
Tangent. Did all of it.
Okay, I got you.
Oh, no.
This starts the function,
Yeah, I have 2,229.
and then like, this parentheses doesn't have anything to deal with, so I think it thinks you're finished here. So I think if you, so we just need more parentheses. So we need parentheses around this part, around the whole thing. And then you need the parentheses around this, that's your original. You just need one more set of parentheses.
This one, I understood.
Yeah, but the way, without this parentheses, you were asking your calculator something totally different. That's why it's used.
It looks a little bit closer to what, how you write it on your paper. That makes it a little bit easier.
That's why there's nothing wrong with this, but if you don't practice it all the time, it's good to have a fallback. Well, Michael, you can start on your 16 AP Stat Khan Academies.
Yeah, I guess.
I thought I gave y'all too many, but now I'm wondering.
Please don't get an idea.
See, those are optional, they're supposed to help us study for the test, but,
For one test, 16 of them for one test?
yeah, cause it was like, it's over 2 units kind of, cause we're doing proportions and means.
weird.
And it's both kind of the same thing.
the answer's
We're doing
probably
one
right.
portion, one.
You mean mean, where you just add them up and divide by the number of things?
Well, yeah, that's what we're testing their statistical significance, so like,
Okay.
if,
I don't remember stats that well, so. I remember sometimes you throw numbers in a thing and you get a number for R, and the closer R is to 1, the stronger it is, or something like
yeah,
that. I remember standard deviation, and that's about it.
we were working with standard error.
I hope I never have to teach a stat class. I'd have to relearn everything.
I don't know how to watch the same video twice, but this is it. Yeah.
Not here. boys? How's the circuit coming?
Not good. I
Okay.
got confused, but we are definitely recharting the course.
See, I asked Harrison for help, but he has like 3 number 13s. So,
Do we really have to call that out?
yeah.
That's how it is.
Yeah, so I don't know what to believe.
I'm confused, like, getting to 13. So.
First of all, what is 13?
Yeah, but that's what we should say. It's way
Well, then we should start at 12.
That's a great point.
So which ones do you want on 12? Where you want to have these? This
Oh,
one.
is it 2?
This one,
Such a weird number.
12 was confusing.
Oh, it's 2? So it's 2.
I don't know. It was, so you gotta, it's right to left instead of up and down.
Would you put those? That's the.
The problem with 12 is there's not always the same function on top and the same function on bottom. If it switches like that, you either break it into 2 pieces and do 2 problems, or you can just do right minus left.
And then you
And then you have to do dy.
Use the Y's.
Yeah, and use the y.
I said that sequence would have to be on top.
Thank you.
Okay, wait, I forgot real quick about the first. You insert them both separately, or you put them in the same place? It's like,
Yeah, if you wanna do it as one big integration.
okay.
You could also integrate this from 0 to 4, and then minus integrate this to 0 to 4 if you want to do them separately. But you can also put them together. That one is just trying to 4/3. Oh, that didn't change that to a fraction.
I lost my.
Oh, yes.
No, I lost them in Disney. And then I broke my wires.
You gotta have that.
Yeah, that's a lot to do with that, right? It comes down to you might try to write it out.
Right.
I can't. I'm sorry. Okay, no, so that needs to be in
You see how this is,
leave y.
I've never seen that before. It is 4/3, but it's just 5.
Would you like me to grab it for you? I just started over.
Yeah, the main problem with 12 is you grab it.
Actually, that's like one of the.
Are we supposed to integrate or not?
Sometimes this is on top. So if it's not consistent with which one's top and which one's bottom, that's when you need to do right minus left. So, cause this one's always on the right and this one's always on the left. But when you do right minus left, you gotta do dy, so that way you can turn the ball consistent.
What did you just say to it? Yeah.
Bro. Streams.
Just maybe a buddy.
I have a telegram. Ready for that? Bird.
Real name? You can, turn it into a vector so you can be done with it. If you have something else to work on for another class, that'd be good. And if it's not, you are welcome to do more from that worksheet from a few classes ago, because I'm gonna ask you to do that next time. But I won't insist that you do that if you've got something else going on.
What's the derivative of secant?
What? Derivative of secant is secant x tangent x.
That's what I've been saying.
Are you sure you don't mean integral?
Oh. Yeah, I have not been saying that, actually.
The thing that you can take the derivative of to get secant squared is tangent.
Yeah, it's secant squared.
Does everybody have to?
Really? Is that law screws?
No, they have practice.
More people selling pie than buying the pie.
I did something. I bought mine. Saving for Apple. Probably such a mystery.
Wait, on 9, how do you figure out where
I like
the?
Mr. though.
Well, we know the points right here.
No way.
Don't think you did.
I just mentioned nothing. Don't say nothing to me that you don't want repeated.
What happened?
You see-
What did I do? Tell her that you call her Katie?
Yeah.
Yeah?
She wasn't mad though.
Of course not. No, he would be mad at me.
That was literally
Yeah, did she tell you what her response was?
She said that I was different outside of class and inside of class. What did she say?
Oh, that was the nicest. There you go, yeah,
Snitch
hey.
on me?
No, yeah. Yeah. Whatever Miss Katie says to me.
So it's a teacher bond thing. She said that I'm much more formal in class than outside of class.
2/3 x over 2.
Or something like that. I'm trying to remember. This was last week.
Can't answer. I don't know.
12.
I need help. From you.
I think we got 4.
Yes. I don't know how you got negative tangent from this.
Yeah, just multiply by like another fraction.
Yeah, so like, this is just not, you don't really need to take away from area. So all of this is just gonna be
How do you use subnets?
Yeah, so how do you get the tangent next per se?
You're subtracting.
I like to say
So it means when
Okay,
they
cool.
rotate
So
down, you can
it's-
separate these two.
Okay.
Oh, you
Yeah, and also you can separate by the, at the negative side into two different integrals.
What? No.
Alright, let me ponder.
Yeah, so it'd be
That's how I did. Number 10.
There's so many on that.
Hard to see where they're done.
Alright. Let's check the word.
Wait, but still, how would I do subnet?
No. You do is like, you think that your u will be 1 plus x squared.
Yes.
But then
And then the u will be 2x. So your u will be 4x equal x, right?
Wait, so you got one. Equate
They equal to
2x.
2 minus 2 minus 1.
Yes, so it's square root x.
That's what you inherit. And then u equals 1 plus x.
By the boundary 0 because
I actually educated guess.
How do I get that? How do I multiply to get that like extreme?
It's good to hear. You can type them on the calculator, but you don't grab it right at least what it's saying.
But it's
I don't think it's a bad idea.
Yeah, what do I multiply the 2
Yeah, what's your solution? Just in the rest.
Oh wait, no, right. This is one of those weird, I think. The same negative understand.
How would I use subnets?
so 1/3.
Because
Like 2x, right?
d
Yeah,
equals
you'll get
2x.
I think I actually felt
It's one of those weird integrals.
I look at the
Ones
different.
that you have that memorized.
Yes.
Well, I've told it to you twice, but I've never told you that you had to know it for a test. It is
Like,
Now, yours will be 8 times bigger than this.
like I guessed. My luck is gonna run out.
I haven't made you memorize the inverse trig functions.
Beautiful.
Now, technically, you can do that in your calculator, so I don't know that you need to know that. This would be if you needed to do it by hand.
Okay.
But that's already this one.
That's already this one.
Seven.
Well, so, I
And what
think
y
it's
looks like.
Sino versus Texas A&M. And then.
This on the,
This
this is website.
See, I haven't messed up. Probably.
What number is this?
Okay.
I think number 16.
No, you see, no, it's not. I'm not, I hate, they're just so.
Is this 101?
Like the state, the state or like the.
Spokane, Washington.
Who even likes the state of Washington? There's nothing there. I think it's people.
Hey, like the state of Washington.
Oh, yeah.
It's like pretty.
Pretty ugly. Oregon's bad.
Oregon
Yeah,
is
6 is
bad.
Oregon's bad.
No,
Is it Oregon?
no.
Might at least handle it.
Oh,
True.
in this fair.
This
Okay, y'all still got about 25 minutes, so you really need to be trying to get this finished. Because if you don't finish this, then I'm gonna ask that you do it for homework, so please try to get as much help as you need.
Mr. Townsend?
I'm running this up.
When I did the calculator, because there are no answers on here that are, 10.
You're just going you get
Yeah, sure.
Did you write on the paper?
That's one downside of using the calculator.
I ain't doing all that.
Negative 1/2 is 1.
I ain't doing all that.
So why would it end up being negative?
If I was too big, I
When you take the, the anti-derivative.
Are you gonna make the assignment due on
Are we gonna follow this?
Thursday?
This?
No, you did this right.
This is due before class hours.
Oh.
Thursday. Did you push back
I
the
started this one last week,
deadline
but
thing
I
on
thought
the last round?
I didn't, but I'll just, I mean, I can keep up with it because I go through and when it's due, I put in grades. And then if y'all turn it in after that, I get an email, so then I know it's late. So that's how I can keep up with it.
Or it'll show up as late though.
It will, but I know the difference
Okay.
before then, but yeah. I guess I could change the date and not have to worry about it, but it's fine.
so.
On the graph, it says calculate the area enclosed by the graphs from negative pi over 4 to pi over 4.
Okay, so.
But there's no way they intersect.
Which question?
11.
Well, the integral of secant squared is tan x.
Mm-hmm.
And the integral.
I thought it was secant x. Or wait,
No,
was it
yeah,
secant
it
x?
is tan x. There, so, and then there is a pi, yeah, pi over 4, tangent pi over 4 is 1.
So what?
So, yeah. I hope I explained it well enough.
How did you know that was on top of? Did you graph it?
Yeah.
You know, what area are you exactly finding?
I guess the area with. I think they're all by. Yeah, I'm not quite sure to be honest. It's a complete one.
Yeah, hold on, this is 3D popularity?
Wait, would you remove the tangent secant squared, right? So.
Yeah.
Negative
One of them is literal
Negative
secant is second.
Yeah.
My balance is negative 2.
Hey, yo.
Alright, the balance is 1 to 0.
They get really fun after.
If y'all have any questions I can help with, please let me know.
0 to 1.
And then,
From negative 2 to 0, do you do the quadratic?
one x cubed. And then on the other one, x cubed plus.
Well, it doesn't really matter. You always, like, it says like a piece subtract up and down. Like you always.
Tangent of negative traveling forward would be negative 1. Negative 5 over 4.
Then, yeah.
How do I do the y?
Well, you gotta, that's just,
Oh, because it's already easier to 1, 2.
yeah, just send this down to the.
So you solve that. Oh, this one? Oh, this one? I don't know. Okay, and so, yeah, you, it's gonna be in terms of y.
Yeah, it's in terms of 1.
Right to left, so you're gonna be the, linear one, but it's nice.
What's the balance though?
intersects the one?
Oh, it's top.
How do you know it intersects the one?
Do you want
How do you know the balance? It's gonna be one.
Well, because I just knew that I intersected that one.
Oh my god, he got his back.
Just imagine the graph in your head.
I need to see your
Like,
photos.
you can just plug it in and like.
Just think about it.
You can graph on your calculator. That options are endless.
I think there's one.
I need to just stop.
Do you know how many types you can have this calculator?
Did it again.
No.
I did this.
Did you
Did you actually
Time for this.
It's weird, it wouldn't be like.
Oh, zeros on top. Oh my god.
I killed it.
You're so gassed.
Doesn't change that much.
Okay, you know what?
Come on, man. What? Does it change your answer?
Well, yeah.
Denominator's right. Each type.
What was it, 8/3? Yes.
Oh, I don't know anything good there.
Do you have to do something?
Where we listen.
Yeah, that's what you do. Two.
No.
What about these?
No.
You get 2 minus X.
Yes.
What's your favorite graph?
My favorite graph?
Yeah.
Favorite graph. Probably the equation of a circle.
It's a good one.
Harrison, what's your favorite?
Sine guy.
You're a sine guy?
Dude, I'm more of a cosine guy.
You serious?
I think it's more.
Any Canadian guys in the room or real?
Good what I thought, you know.
Cosine's,
No one likes
cosine's
it.
more aesthetic.
That's fair.
That's why I like sine curves a little more.
What about cosecant, guys?
No.
Shut up.
I just think it's interesting you all pick trig graphs.
No, yeah, that's weird.
I wouldn't do a trick graph.
I'm a good, I'm a good,
There's no way you really just chose.
The V? You kidding me?
absolute,
Vector.
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 My brain. Find much. Look, mine, oh my god, so you know I'm doing we had to do a whole extra day of work this weekend, so I was working for like 8 hours a day, like I worked 16 hours.
Yep.
I'm full of love and joy. No, it's not. I mean, it was fun.
So like which is
I just could have
subtracting
also been working and I kinda wish I was. I wanted to
Positive
stay.
minus
Yeah. Because.
Sure. That's cool. What is that? That's pretty cool.
Remember this one?
I solved where they intersect, but that option doesn't work. It's plugging in 1/2, and then that gives you 1/4, and that, so you would have. No, that gets you 1/2.
Well, if you graph them, the difference in number 12 is sometimes this function's on top,
Yeah.
this one, and sometimes this one's on top. So it just depends on which part you're looking
Most of it
at.
comes out the same.
Wait.
So top minus bottom doesn't really work very well in this question because of that, unless you try to split it up.
I don't know why.
So I did right minus left instead. This one's always on the right and this one's always on the left.
Last one. Here we go, Philip.
But if you choose to do it this way, right minus left, you gotta do dy, and the other stuff is gonna be y. So that makes that part a little bit harder.
Wait, what do you mean right left minus left?
The rightmost function,
Oh,
subtracting
okay.
because I'm really finding this area to the y-axis, and that's subtracting this area that's not there.
Yeah. Yeah.
So there's just a different option, but I
Okay.
think it's easier on that one.
Oh, yeah.
But it's still not an easy question. But sometimes right minus left is better than top minus bottom. I think on 14 I did the same thing.
Wait, what did you get for the intersection, or what were your zeros?
That's what we use one.
What? 2 and, or x minus 2 and
Well,
then.
mine are in terms of y, but I did it the other way.
Oh,
Mine are
okay.
negative 1/2 to 2.
That would not be
Okay.
4/3.
Because, but these are, when I plugged in 1/2 there, I get, or
Which is bigger?
Well, part of the problem is when you solve it this way, this is why I'm not
Yeah.
cranking it up this
Or
way.
e minus
The
2.
last thing you did was you took the square root of both sides. So really it's supposed to be plus 1 minus.
Oh, okay.
Plus one.
And then that kind of complicates how
Oh,
you
no.
work with it. Because if you only have plus, you have this half of the graph. You don't have that half of the graph.
Yeah. Oh, that would make sense, cause if that's plus or minus, then that could be one, it has the potential to be 1/2, if you plug in negative, or if you plug in 1/2 there. Because the square root of 1/4 is 1/2, and then it has the option of being minus 1/2, because if you plug 1/2, then for x there, it's negative.
No way, we got it.
Okay, yeah.
Yeah, so I'm not saying that you shouldn't try to finish that because you're pretty far into it, but if you don't end up with 9, and you have to start out, you might try to write minus left instead.
Okay.
Just as a different option. Anybody know why they have the bells turned off today?
I saw this. Some people
Extended time
testing.
for the testing.
Oh, I don't know. That's why I was
Or
asking.
retakes or something. I thought I saw that this morning, the advisory going on positive.
Oh yeah, they are doing ELPA. I see it now. It's only 8 students though. Turn off the bells for the whole school for 8 students.
I mean, that shows they care about is the value of each individual student.
Okay.
Only for standardized testing only works in absence.
But also, why are those 8 students testing today?
Yeah.
Because they didn't come the first time.
Or there was I had a friend who had to retest because her name was cut off the testing list and she didn't get for testing.
I don't know. This is probably a different test. Each test kind of has different rules behind it.
Oh, you didn't use it.
I know.
You didn't use it. Oh, wow.
Hey, anyone got an eraser?
Notice.
We got one over coffee down.
It does fun.
Thank you.
Is anybody going on any nice vacations over spring break? It's not taking you with him?
Oh, where?
Well, he's
Where at?
good for work.
Buffalo.
Oh.
Oh, you might have known.
I think it's here in Arkansas.
Yeah, when are you going? I don't know.
But it's not good weather apparently over spring break, so I don't know, it might be.
But, we're going there, Thursday, Friday.
Thursday, Friday, yeah, that's what I'm gonna do.
Also, if I
Oh, yeah, me too.
Well, hey, if you are there
What?
Thursday,
I
Friday,
said if I win, I'd miss Friday.
give me a ring.
I'll start slapping the waters. Can you read it?
Or like, what is this guy doing? You know?
How did you figure out the next one's 2 students? Did you pull your,
I'm trying to teach you chemistry. Dude.
And whenever he is, it's gonna be less.
Yeah, but like,
Yeah.
when he said that,
Doesn't
I
matter
said
what
it
it is,
was
because
because
it's
it's
like,
other than that, we're supposed to be more.
and as long as E over E is 1 over, is 1 over E. That's what really much. And it's like, no, it's less 1.
All right, we've got just a couple minutes here, so let me remind you, if you did not finish this circuit, number 101 in your binder, please use the videos on my website to try to help you finish it. Please try to do it tonight so that if there's some that it's still not working for you, something doesn't make sense, the video's messed up or anything like that, whatever the case may be, you can stop by tomorrow during advisory and get some help. I will ask for this. Well, it's open in Google Classroom, so I really want you guys to turn it in before class on Thursday.
Wait, it says it's due at 2:25.
Well, I wanted y'all to finish it in class, but then I realized that some of you didn't get as much done on it last time, so.
Okay, but will we get late?
No.
Oh, okay.
As long as I get it by the start of next class, you'll still get full credit.
Mr. Townsend, hey, sir, could you show me again?